The ordinary least squares estimator. The ordinary least squares estimator chooses the regression coefficients so that the estimated regression line is as close as possible to the observed data, where closeness is measured by the sum of the squared mistakes made in predicting big Y given big X. As discussed in section 3.1, the sample average big Y bar is the least squares estimator of the population mean. The expected value of Y, big E of big Y, that is big Y bar, minimizes the total squared estimation mistakes. The sum of I equals 1 to n of big Y sub I minus m, and that'll be squared, among all possible estimators m. See expression 3.2. The estimator extends this idea to the linear regression model. Let B sub naught and B sub 1 be some estimators of beta sub naught and beta sub 1. The regression line based on these estimators is B sub naught plus B sub 1 big X, so the value of big Y sub I predicted using this line is B sub naught plus B sub 1 big X sub I. Thus, the mistake made in predicting the ith observation is big Y sub I minus open B sub naught plus B sub 1 big X sub I close equals big Y sub I minus B sub naught minus B sub 1 big X sub I. The sum of these squared prediction mistakes over all n observations is the sum of I equals 1 to n of open big Y sub I minus B sub naught minus B sub 1 big X sub I close squared, equation 4.4. The sum of the squared mistakes for the linear regression model in expression 4.4 is the extension of the sum of the squared mistakes for the problem of estimating the mean in expression 3.2. In fact, if there is no regressor, then B sub 1 does not enter expression 4.4. And the two problems are identical except for the different notation open bracket m in expression 3.2, B sub naught in expression 4.4, just as there is a unique estimator big Y bar that minimizes expression 3.2, so there is a unique pair of estimators beta sub naught and beta sub 1 that minimizes expression 4.4. The estimators of the intercept and slope that minimize the sum of squared mistakes in expression 4.4 are called the ordinary least squares estimators of beta sub naught and beta sub 1, or we can call them beta sub 0 and beta sub 1. OLS, the ordinary least squares estimators, has its own special notation and terminology. The ordinary least squares estimator of beta sub naught is denoted beta sub naught hat. And the ordinary least squares estimator of beta sub 1 is beta sub 1 hat. The OLS regression line, also called the sample regression line or sample regression function, is the straight line constructed using the ordinary least squares estimators beta sub naught hat plus beta sub 1 hat big X. The predicted value of big Y given, the predicted value of big Y sub I given big X sub I based on the ordinary least squares regression line is big Y sub I hat equals beta sub naught hat plus beta sub 1 hat big X sub I. The residual for the ith observation is the difference between big Y sub I and its predicted value U sub I hat equals big Y sub I minus big Y sub I hat.